Geometry lesson on rotation and investigating symmetry. So guys, 2.3 is rotations and 2.4 is the second topic. So this is a combined lesson. It makes more sense this way. All right, guys, warm up. Are you ready? Okay, pause the video and try your best. Okay, guys, the answer is the first quadrant and a second quadrant. So let's examine why that should be the answer. The image from rotating figure in the third quadrant 180 degrees clockwise. So for number 3, oopsie, that's really thick. Let's go with that one. So we have something like this over here, guys, right? In the third quadrant, that is 1, 2, 3. So let's say you have something over here, guys. We are rotating something 180 degrees. So it's kind of like having a compass, right? Centered over here, open that all the way to this way, and you're going to rotate it this way, right? As it turns out, guys, when you do that, when you go 180, it's like going the opposite direction. Isn't that what we mean when we say, oh, somebody so-and-so did 180? Right, exactly. So what you could do instead is just draw a line through the origin, just like that one. And if you go the same distance this way, let's say that's a P and that's a P prime, that is 180 degrees, guys. In this case, clockwise, oopsie. So as it turns out, for 180 degrees, it really doesn't matter. The clockwise goes this way, right? For 180 degrees, clockwise or counterclockwise, will get you to the same spot, but you travel in a different path, right? So from third quadrant, the 180 degrees is what is diagonally across it, which is first quadrant, and vice versa. So if you had a second quadrant, 180 degrees will be fourth quadrant, and vice versa. Okay. All right, guys, that was number 3. Let's get number 4. Image rotating a figure in the first quadrant 360 degrees. Well, if you have that, oopsies, let's go with this one, right? Copy, paste, have something like that. Ooh, let me just put this back better. There you go. So when you do this, we have point P over here, and you're basically doing the same thing. You're just rotating this around the whole around clockwise. Oopsie. That was counterclockwise, wasn't it? I'm making a lot of mistake. So this is a clockwise this way. It's the same exact point. Hence, what starts in the first quadrant stays in the first quadrant. Looks good? All right, guys. Let's move on. So we have to have the use of protractor and a compass. And it's kind of hard to show you using a video because I don't have this fancy animation tools, but we'll do what we can. Okay, with a little bit of imagination, I think we could do this. In the figure, the center of the rotation is P and the angle of rotation is 180 degrees. So what you would do is put a protractor like this line from point A to the center of rotation like this, right? Put a protractor line, the bottom line over there, and you do that. And if you connect, you would see that that'd be 110 degrees going this direction. And you would draw, let's say, connect a line this way. And then you kind of, using a compass, widen the compass this way to measure that. And if you transfer over that over there, it should work. Then you know it's been rotated 110 degrees. All right, guys. So how could you do this, right, with this? So you know to do 150 degree rotation, you got to take each point. A, B, and a C rotate 150 degrees. And if you do that to all 3 of them, you connect those, and that will be the correct answer, right? Looks good? All right, why don't you give that a shot and see what happens, all right? By the way, rotation is a transformation around P, the center rotation such that the following rule is true, right? Number 1, every point in image is the same distance from P. So for example, from AP is equal to A prime P. And the angle formed with vertex P and the using the point and its image have the same angle measure. That's angle of rotation, 110 degrees. So far, so good. All right, let me see what that would look like, guys, if you do that. Well, I couldn't really do it online, so I did it on a piece of paper from last year, actually. And I just took a picture of it and I uploaded them. So I basically drew using a compass, I just drew a circle this way with center O, point P, and point P to the B, I just drew a circle around it. I did the same thing with C. And using this line, I used a protractor to go this way. I measured to be 150 degrees. And I did that for A, P, A prime, B, P, B prime, C, P to C prime. They look about all the same, right? Yes. On my protractor, I measured 150 degrees to all of them. And I connected A prime, B prime, C prime. And look, it's the same exact shape, guys. And that is how you do them. Okie dokie. All right, guys. So we're going to learn some rules right now. Like doing that, like algebraically, it's very challenging for 150 degrees, but we do have a way to do it for other angles that are a little bit more manageable, right? And that's exactly what we're going to do. In this particular case, we're going to say, hey, let's rotate this thing, right? 270 degrees, shall we? If that's the case, what happens? Now, it doesn't say what the angle is, 270 degrees, right? Then how would I do this? Well, with 270 degrees, we usually do rotation, I don't know if you noticed, counterclockwise. That's right, counterclockwise. Okay. In trigonometry and whatnot, we actually go rotate this from positive x-axis like this, counterclockwise this way. Okay. I couldn't tell you exactly why, but that's what I've been doing since I was your age. Okay. So what is the rule? Okay. For those of you looking at the bottom, yeah, we actually have a rule. I could give it to you, right? But we did some of them already, right? For this, it was negative x, negative y. Do you remember that? For 360 rotation, it remains the same, right? For 90-degree rotation, from like past whatever, it's negative yx. And the funny thing about 270 counterclockwise is actually you swap the two, but you negate the different one. Okay, and we'll figure out why. Okay, you could memorize it if you like, but I think you should at least try to figure out first time on your own, and then it will make more sense to memorize. Okay, so the rotation of the image xy as at 270 degrees counterclockwise, that's implied counterclockwise, is indeed y and negative x. And let's do it for ourselves, shall we? So if we have, let's say, point of rotation is the origin, and if you want to go around this way, 270 degrees, is not basically going this way 90 degrees? Right, it has to be perpendicular. 90 degrees is perpendicular. That's the thing. That's the key. And now we go, hey, that is 1, 2, 3, 1. So that point is 3, 1. So we know that the slope over here is 1/3, isn't it? Goes up 1, right 3, 1/3. The negative reciprocal of that, if the slope is 1/3, the perpendicular slope is opposite reciprocal, which is -3. So what that means is that for that particular one, I just go 1, 2, 3 this way. But because we're doing counterclockwise, 270 is equal to 90 degrees this way, right? Oh, look at that. Looks like this is 1, 2, 3, 1, but here it is 1, 2, 3, 1. I see. So my y value, this one, 1, 2, 3, -3 was the opposite of this right here. Okay, let's write this out. Maybe we could see that better. Okay, so that was 1, -3 from, let's pull that down just a little bit so we can see better. All right, so that's D, right? So it looks like we swapped these two, right? This way, and I negated the second one. And if you do that a couple of times, it kind of makes sense. All right, so we're gonna apply the rules now, guys. A, as it turns out, is 1, 2, 0, 2, and B is 1, 4. And then we got C, which is 4, 2, and the D is 3, 1. When we swap and negate the first one, it became what? 1, 3, 2, 4, 4, 1, and 2, 0. And for the second part, the Y part, over here, we just put a negative sign in the front. We're going to put a negative, 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 but -0 is still negative, so it really doesn't matter, right? So I'm going to put all that in a different color. Let's change the color here, guys, okay? Let's make it magenta, okay? So A prime would be, let's make it magenta as well, is 2, 0. 1, 2, that's A prime. B prime is 1, 2, 3, 4, -1, that's B prime. C is 2, -4, which is right there. And D is 1, 3, which is here. So this is A prime, B prime, C prime, and you know what? Let me erase this part right there, right? And that is D prime. So when I connect them, oopsie, there you go. Let me try to pull this out. See? You know what? I think I would be better off just drawing that line again. This way. All right, so if you look at it, it does look like it went around this here to here, this way, right? It was more like this, right? How about OB to OB prime? Yeah, that looks like going this way, 270. So that's how you kind of check it out, okay? All right, guys. Yeah, I know it could get a little confusing at the beginning, but let's just keep at it, shall we? All right. So we have rotation, specifying rotation of the angle. Yeah, this one, if I give you that, I don't know how I'm going to give you this online, but in a physical class, I would have this kind of question, right? How would you do that? Well, one of the ways is to actually for you to connect A to the point of rotation, the center of rotation, and to its image like this, and measure the angle. And if you had a protractor, it should give you 80 degrees. Okay, so what happened? Well, step number 1, this is what you do. Find the angle measure A, P, A prime. The middle one is a vertex. The vertex over here is always the point of rotation, the center of rotation, right? By, number 1, drawing. Oopsie, sorry about that. By drawing segment AP and A, B, A prime. Step number 2, right? Measure the angle A, P, A prime using a protractor, right? And by looking at that, by doing so, therefore we see that the angle of rotation is 80 degrees counterclockwise. If I don't use the word counterclockwise, we're just going to assume that it is counterclockwise, but generally it's a good idea to use them. All right, guys? All right. We're doing okay with time. So let us, yeah, so this is actually the answer. I copied paste from the book. So it essentially says the same thing. I showed it to you using my own words, but that's the wording that was used by the book. Okay, guys? All right. And 2.4. Let's talk about symmetry. Okay. So figure has a symmetry, right? If a rigid motion exists in a map, and then it maps to itself, right? And the figure has a line of symmetry or reflectional symmetry if a reflection map maps the figure onto itself. So basically the easy way to think about for me is a right there. If you're folding on paper, this would be like a fold line. So you ask yourself this question: in this particular shape, where can I fold so the points overlap? If you said this right here, yeah, I think so too. So that right there, I would call it the line of symmetry. And when you look, if you call this A, B, and C, this line is the same length. Yeah, that's it. We're done. Okay. So it's a mirror image. So there's a mirror image about, let me write this down, okay? There's a mirror image, right, about the line of symmetry. All right, guys? There you go. Okay. So try this if you can, right? How many lines of symmetry do you see? We're talking about lines of symmetry, guys. Lines. Not any symmetry, but line of symmetry. Okay, great. The first one I got 2. Let me change the color to blue. I got 2, 0, and 1. And the one I have is that's the first line, and that is the second line of symmetry here. Yeah, man, it's you could tell this length is different from this length, which is different from this length. So it cannot fold onto itself and the points match. But you could imagine that if you fold a line over here, these points will match. And all the lines like this. And same thing happens with this line. How about the third figure? Yeah, if you draw a line this way, it's going to work. So I'm just going to draw a line this way. Okay, guys? Then this is the same, and that is the same. Maybe I should have done that. Are we good, guys? All right. So let's talk about a rotational symmetry, right? There are different kinds of symmetry. The one was line symmetry, and we're going to identify the rotational symmetry over here. Figure has a rotational symmetry if rotating a map, right? If the rotation maps the figure onto itself. So if you rotate this star like this much, this point becomes this point becomes this, that point becomes this, that point becomes this, that becomes that, and everything will look exactly the same. And the way we figure this out, guys, right, is it's actually pretty straightforward, right? Look at all the points that are all the as furthest point out on the star, and if you draw a line this way, guys, this way, this way, this way, this way, and this way, and assuming that this is a regular shape, there are 1, 2, 3, 4, 5 areas, and full circle is 360. So 360 divided by 5 is 72 degrees, right? So what that means is that we move 72 degrees this way, right? That was unnecessary for me to write because it says so right here, okay? All right. So we have angle of rotation is greater than 0, but less than 180 degrees. The smallest angle of rotation in the map rotation that maps the figure onto itself is that. Okay? All right. How about, let's see what's going on. Oh, that's it? There you go. I'm sorry, guys. This should have been on the other page. Let me see what I could do. Copy. And you know what I should do? I'm going to copy this right here. Copy. And maybe put it right. Cut. Sorry. Let me see what I could do. All right. Let me choose that. I'm going to copy this. And let me put that over here. And for whatever reason, I can't seem to make it bigger. Anyways, I'm sorry. So you know what I'm going to do? I'm going to grab it. I am going to cut this. Okay. All right. So you guys, I'm sure, was printed out properly. So determine the rotational symmetry on this particular shape. And yeah, it's exactly what you think it is. You go this way, and this way. There's 1, 2, 3 of them. So 360 divided by 3 gives you 120. In other words, that rotation is 120 degrees. So the rotational, the angle of rotational symmetry in this case is 120 degrees. Okay, guys. Why don't you guys go ahead and try this on your own and pause the video. Okay. So what do you think? So we didn't give you the point, but generally speaking, the point of rotation is right in the middle of the shape. In that case, it's this one, right? And there's 1, 2, 3, and a 4. So 360 divided by 4. In this case, it's 90-degree rotation. This is none because it's a irregular shape. And this one over here, guys, right in the center, right there. That's one side, and that's only two sides to that, right? So 360 divided by 2 gives you 180 degrees. That was it, guys. All right. So what I'm going to do is there is a ticket to leave. We're going to be working on this we're going to be working on this in class, right? But if you'd like to get a head start on it, and we'll have a full discussion, but try it on your own. But I will show the answers, right? But pause the video first. Okay, guys. So the answers to these are these. I will just zoom in a little bit so you can see better. Okay, I'm going to slide it up. And there you go. The next page, this one, the correct answers were over here. Let me zoom in a little bit more. So there you go. So number 6 and 7, answers are like that. I'm going to slide up now. And there you go. Actually, you can see, there you go. You can see all of them now. Okay. So we will discuss this in class, right? All right, guys. Thanks for hanging around. I'll see you tomorrow in class. Bye-bye.